Hello, my name is Lingwen, and in this video I will present my time serial forecasting project on visa application data. And I analyze the history visa application data published by Ireland government and build predictive models to forecast future application trends. And I will go through the entire process from data loading and cleaning through exploratory analysis and to modeling, and finally evaluating the impact of exogenous variables. First, the data, we do the exploratory data analysis and data cleaning on the visa application data sets, which is downloaded from data.gov.ie, the Ireland government data sets. And to understand, we should first to understand its structures, identify issues, and prepare it for modeling. The dataset contains the months. The monthly visa application counts from 2017 to 2025, broken down by visa types, short-term, long-term, and also DCR status, received, guaranteed, or refused. And there is at first we check the missing values, and we found that the missing values in months September, October, and December. That because the data connection ended in August 2025. So we should confirm to limit the data set to months before September 2025. Then we do the data cleaning, and we should the months are in the column is a wide format. We should transform the data to a long format, and one column for months and one column for the counts. And we can see that there is about 600 rows. Now this shows a sample of the final data frame, and the date are constructed with year, months, and we assume the day is the first day of the month. From 2017 to 2025. And we also add a year column for the potential temporary analysis in the fourth section. They also have different tabs and status. And we check the count. The data tab has object is non-numeric value. We need to convert it to numeric with pandas. And we can also see there is a null value in the count column. We need to handle it before processing. In this method, we use the linear interpolation to fill the missing value. Now there's no null value. Besides that, we also should prepare the time serial data. We can group by the date, type, and status. And we also create data frames with all the variables, such as short-term received, short-term guaranteed, short-term refused, and also the long-term. This is the final data frame. In the second section, I focus on visualization of visa application data to identify trends, seasonal patterns, and the impact of external events such as the COVID-19. First, we draw a box plot, show the spread of the application counts per status. They have some similar patterns. Then, we do the time serial trends, show visa application trends over time separated by type and status. Here is the result. This plot clearly shows a sharp drop in application during the COVID-19 pandemic, especially for short-term applications. There are less impact on the long-term applications. This plot clearly inform us that and inform my decision to test models both on the full dataset and on the post-COVID dataset. The third part is model creation. I build and compare forecasting models using a RIMA and a gradient boosting regressors to predict future visa application counts. First, I select the serial for short-term visa application received by the target variable. And we use auto RIMA from PM.RIMA to automatically select the best RIMA parameters. Models was trained on all available data. And we generate a 12-month forecast. And the forecast shows a moderate seasonal pattern. There are higher applications from May to July. And we draw the plot. Then I use the post-COVID data and train the RIMA data from September 2021, which is onwards to avoid the COVID-19 distortions. And it has a quite a different predict, and the forecast value are higher, which shows a rising trend, suggests a recovery. And this is smoother. Besides a RIMA model, we can also use the gradient boosting regressor model from scale forecast library. First, I defined a machine learning-based forecaster, and the regressor is a gradient boosting regressor. And then fit the model using the trained data, and then they get a predict. This model was trained using a path values lag, and compared to ARIMA, the gradient boosting regressor model captured more recent trends and produced a different forecast pattern, showing how machine learning can offer an alternative perspective. Both ARIMA and gradient boosting regressor model are successfully trained and used to forecast these applications. ARIMA provides a smoother seasonal forecast, and gradient boosting regressor capture more recent trends. And the choice of the training period, that is the first data or the post-COVID data set, significantly impact predictions. In the fourth section, I explore the use of exogenous variables to improve forecasting accuracy and test a customer function to generating internal prediction. First, we defined our own function to generate exogenous data prediction. And then select exogenous variable based on the correlation analysis. And the exogenous augmented model produce adjusted forecast demonstrating how additional predictor can refine predictions. Now, however, the integrating exogenous variable also introduce a complexity, which is an area of further tuning. And this is use ARIMA, and this is use gradient boosting. So at the end, we do the summary. This project successfully conduct EDA, data cleaning, visualization, and time series forecasting on this application data. Two forecasting models, ARIMA and gradient boosting, are implemented and compared. Challenges were encountered with exogenous feature integration, pointing to areas for future improvement. The analysis provide actionable insights into these trends and a foundation for predictive models in mitigation policy handling. Thank you.